Hi, everyone. Welcome to our video submission for WPI's virtual internship in biomedical engineering. Our project is entitled The Fight Against Malaria. Our group is made out of 4 team members.
What is malaria? Malaria is caused by a parasite which is spread by the bites of female mosquitoes. So why is it important? Every year it affects 400 to 500 million people and more than 400K lose their lives. So every diagnosis and treatment of malaria reduces transmission and prevents death. Most symptoms appear after 14 days of the infection. So there are 3 stages: the cold stage, post stage, and sweating stage. So if not treated immediately, it can be fatal. So availability of malaria blood testing among all screened public health facilities around the African subcontinent is insufficient. Our diagnostic device aims to create an inexpensive tool to be used in limited resource areas.
Our product applies 2 techniques, one which is the lateral flow sandwich immunoassay used in a pregnancy test, and the other is removing red blood cells infected with malaria by using a magnet. There are 5 different strands of malaria. The 2 strands we're testing for is Plasmodium falciparum, which is the most deadly, and Plasmodium vivax, which can remain dormant for years.
Malaria is most present in sub-Saharan Africa and Southeast Asia. However, roughly 50% of the world's population is at risk for this disease. We decided to focus on Burkina Faso and Sierra Leone because in these countries, malaria is in the top 3 causes of death. Our device is easy to use and does not require a lot of training. In fact, the only training that is needed is being able to draw blood.
Instead of providing black-white results of whether malaria is definitely present or not, the device aims to provide information on some of the molecules and magnetic properties of blood characteristic of being infected with malaria are present. And so we are testing for 3 main components: the presence of malaria of any strain, and for 2 specific strains, the Plasmodium falciparum and the Plasmodium vivax. So for detection of any strain of malaria, we're searching for a shared enzyme among all strains and also infected blood's magnetic property. And then to detect each of the 2 strains, we're searching for 2 different surface proteins for each. And so our device has a disposable test strip for each patient with zones, antibodies, and other chemicals that allow us to perform the test. And then these are inserted into a reusable cassette, which has open lanes to see the color test lines or not, and a place to attach the strands to draw the blood.
The first step is to draw blood from the patient. Our syringe comes with a needle and a detachable tube, which will be filled with blood. Step 2 is to get the blood into the device. We do this by attaching the tube of blood into the corresponding inlets on the top of the device, and a button is pushed back to allow the blood to reach the cellulose pad on the inside of the device.
The blood flows to the conjugate pad, and here the antigens we are searching for get attached to the gold nanoparticles via the different antibodies on that pad. And there are 6 test line totals. A colored line means a positive result. So for lines 1 through 5, there are immobilized antibodies on that test strip, and a colored line will or will not appear based on the presence of certain antigens as the gold nanoparticles from the previous zone accumulate if the immobilized antibodies on the lines bind to those antigens. And the 6th line instead has magnetic beads to track red blood cells and leftover gold nanoparticles if the blood is magnetic.
The goal of our device is to make sure it's easy and accessible to a wide range of places. We hope this device also helps with triaging of those that are infected with malaria to ensure proper treatment. Since so much of the world is at risk for malaria, it is extremely important to not only create the device, but to get it to where it needs to go. This is where outside influences will be essential for our success. We plan on working with NGOs whose goal is to help fight malaria. Our company will be aided by donations, and profits from the device will go back to serving the communities we help. We plan on allowing the areas we work in full control of how much intervention they receive, being mindful of their traditions and wants. Thanks to everyone who watched this video, and we hope you give it a like.